So, hopefully you're all still awake after 2 days of really great technical content. So, my name is Gareth Emslie, as Ricard announced earlier, and I'm a hyperscaler strategist at Dynatrace, right? And in my spare time, I also do some evangelism, right? So, Dynatrace allows me to actually work in this space as well, right? Which is great. So, I'm really excited to talk to you today about leveraging ChatGPT and generative AI in the observability space, right? I know a lot of you are probably, obviously, it being a DevOps conference, a lot of you are working in that space and are really interested in kind of getting issues resolved as quickly as possible, right? Okay. So, this is my standard disclaimer. Basically, I don't claim to be an expert in all the topics that we're going to discuss today, right? I'm just excited about the technology, and I want to share a little bit of the information that I've discovered over the last months, right? So, oopsie daisy. So, how many of you care about observability? Just a show of hands. I think you should all have your hands in the air, right? High in the air. So, why do we actually care about observability? Well, Werner Vogel, I think, summed it up very well, right, with his quote, "Everything fails all the time," right? So, he was really emphasizing the importance of designing designing reliable systems, right? And the fact that the platforms that we run on historically are prone to failure. So if we look at some of our modern platforms that we're running on today, right? So the hyperscalers, for example, they have outages all the time, right? I don't know, you probably have experienced it, obviously, being in the DevOps space. But if we look at the timeline of the last, over 2022, at the top 3 hyperscalers, right? Google Cloud had a number of outages, but in January, for example, they had a routine maintenance event where they had made some configuration changes that caused an outage in one of their regions, right? In March, again, a change to the traffic director code caused another outage, right? Azure, of course, is also not excluded from the club, right? So Azure in June had an unplanned power oscillation. I think somebody tripped over the cable, maybe, in the data center. I don't know, right? It took down one of the AZs. In July, this is actually my favorite, a heat wave in the UK knocked out data centers in London because of a failure to the cooling systems. Amazing, right? And it goes on and on, right? All throughout the year, we can see every month there was an outage. So what is the key learning for us, or the key takeaway? We need to design reliable systems, right? Systems which are highly available. The fact that the hyperscalers actually put in their documentation that the onus is on the customer to actually design, these highly available systems, can't be forgotten. So another problem is that the cost of downtime has just exploded, right? In 2014, I think, Gartner calculated the cost of, of downtime per minute was $5,600. That was in 2014. And systems have become far more complex over the years. So this number has been steadily rising, right? Just in the manufacturing industry, for example, it can cost up to $260,000 an hour for unexpected downtime. In the IT industry, even worse, right? $450,000 per hour if you experience unexpected outage. Auto industry, $3 million. And I think the one that takes the cake is enterprise industry, right? Up to $5 million an hour for outages. Obviously, Sorry, the clicker is a little bit quick to jump to the next slide. So obviously a number of factors play a role, right, in driving these costs up, such as the industry, the size of the business, and the business models, right, of these enterprises. So some of the challenges that we're really trying to solve today in observability are things like the increasingly complex multi-cloud environments, right, which customers are actually deploying to. The sheer volume of data. So the data volume has exploded over the years, right? And along with that, the number of alerts and the alert fatigue which this causes is causing a lot of pain for operations teams. Historically, also enterprises have designed or have built siloed organizations where IT, for example, infra, dev, and ops are very siloed. They don't talk to each other. You just throw the software over the wall. And also business teams are also siloed. So this leads to loss of key insights, for example, and understanding of how systems should work. Correlation of events also has been historically very challenging, right? Obviously, observability vendors have done a great job to surface a lot of these events and try to correlate this data for their customers. But historically, it's been very challenging, right, for enterprises. And this is really, how do they understand what actions cause the specific scenario, right, within their solution? Something I think that all of us are also very concerned about, right, is the fact that the risk of IT outages is certainly set to grow further in 2023. And this is due to the fact that there have been mass layoffs across the IT industry, right? Just in 2023 alone, over 1,000 companies let go over 240,000 employees, right? This is extreme risk for these organizations, right? Because obviously it was caused by the economic downturn, but there's a loss of this institutional knowledge, right? Where they let somebody go. This increases the potential of further failures, obviously, and outages. One good thing about this, I suppose, is that enterprises are forced to reprioritize their disaster recovery planning and focus more on these aspects of their business to shore up their business and make sure that they don't actually experience these outages. They also are now forced to perform further testing, right, of these systems, of these IT systems. So something else that a lot of you are probably doing as well is that we have to proactively mitigate potential IT risks before they happen. But we have to think more carefully about it because of the fact that we have far less resources to do the things that we used to do in the enterprise. Okay. So modern observability platforms, name the platform, but really what they're trying to build is a cost-effective and unified platform for their customers. Right? They're looking to predict outages before they happen, right, to save their customers money, essentially. A lot of these platforms also provide smart alerting, right, to try to limit alert fatigue, to help operations teams deal, with the deluge of incidents and alerts that they receive every single hour, in some cases. These platforms also work very hard to try to correlate events to causation, right? So they try to help you identify the root cause of an issue and also the resulting incident. The goal there, again, is to reduce the time to actually resolution. Okay, so let's talk a little bit about machine learning and AI, right? So obviously today, many companies, not just the observability vendors, many companies have been using machine learning for years, right? So if we look specifically at observability, we have been leveraging predictive AI, so very standard machine learning practices to do forecasting, anomaly detection, and those kinds of things for years now. Right, there's nothing really new there. We've also been doing causal AI. So here we actually look at our entity model, we do trace traversals, and we look at the domain context, and we try to also detect anomalies, right, before they happen in these platforms that we're monitoring. So it makes a lot of use of fault tree analysis, for example, where we look at, it's a top-down approach where you look at the components in a system, component-level failures in the system, to understand a system-level failure, right? So the predictive AI and causal AI together have really met the customer's needs, until now. But, we have to go a step further and look forward to the future. So I don't think any of you have missed the news or, on Twitter, on LinkedIn, on, whatever news, even your parents probably know about these things today, right? The GPTs and ChatGPT, generative AI. So significant progress has been made with large language models in recent years, right, since around 2017. So it was all triggered by, I think, a paper by Google, where they introduced transformers. I think we'll go through a little bit later. But this really drove a lot of the innovation that we're seeing today with large language models, and a lot of the cool tech that you see out there today, like leveraging text summarization and generation of text, code generation, image generation, a bunch of different useful scenarios where large language models excel, right, and can be used really effectively. So I think you've seen a couple of these logos probably before. Has anybody tried, for example, GitHub Copilot? Okay. Yeah, I mean, it's a great concept, right? You have a co-pilot, somebody to help you do the boring stuff. I think this is an excellent example of leveraging this technology. And of course, there's other things like the image generation, DALL-E and Midjourney, which is pretty great as well. Obviously, there's some concerns there, but around copyright and that. But I think all those will be solved in the future, I'm sure. Okay. So large language models, in essence, are based on deep learning neural networks. Right. We're not going to go into a lot of detail about this topic, but it's good just to understand the basics. Right. So on the left-hand side here, you can see, sorry, on your left-hand side, you can see a deep neural network, right, made up of multiple layers. Right. Some input layers, output layers, and some hidden layers in between. And we can see, just as an example, that we have a picture of a dog, which is encoded into essentially numbers or vectors. It's run through the model, the neural net, and different weights and biases are applied. We'll see a little bit later how that works. And finally, the output is the fact that it detected a dog, right? So there's some encoding and decoding going on because these neural nets really understand numbers. They don't understand like vision, for example, as we understand it, right? So here we can see an example of a single node. So it's basically the same. So you'll see there's a neural net within the node with different weights and biases applied to that. Okay. So something which is very interesting is that, large, deep neural networks are pre-trained on the entire internet, or the whole internet. Now that should scare a lot of you, because there's a lot of wonderful content on the internet. But anyway, it's not really the whole internet, right? I mean, so let's look at how we actually train one of these, just at a high level, how we select the data and that. So data quality is obviously key, right? If you want to get good output, you need to put good input into this, and into the training of the model. So you need to select some raw data. And there are lots of data sets out there which you can make use of, right? Like Wikipedia, for example, or Kaggle. You then apply quality filters, right? So you, for example, make everything lowercase, you remove any stop words, etc. A couple of things which help improve the performance, right, of the training. You then remove any duplicates. So any duplicate data, it goes out the back door. Another critical aspect is removing personally identifiable information, or PII. So secrets, ID numbers, CD keys, whatever, you know. Remove that stuff. Finally, all this data goes through tokenization, right? So it's where essentially the text is broken up into tokens, and tokens could be one or more words. There are a number of different tools online where you can copy and paste some text into a text box, and it'll actually show you how the tokens would be calculated, right? Or which parts of the text would be considered tokens. Okay, so that's one important fact, right, we've just gone through. So data quality is key. This is how you select the data for training these models. Another aspect is, so as you train these models, you can also optimize its performance, right? And this is done through parameters. Now, just some of the parameters are weights and biases, for example. So weights and biases, they're essentially a link to the individual neurons, so in the neural network, which we're using to actually build this model. They're initially set to random values. And then as you feed in data, and as the neural net and the model is trained, these values are updated, right? And then you're able to tweak these weights to improve the performance, right, over time as you train the model. Another aspect which has really helped to improve large language models in recent years is reinforcement learning, but with human feedback. So the way this works is we take a pre-trained model, like GPT-3, for example. We demonstrate, okay, you know, this is what a good prompt looks like and a good completion looks like, right? So now we've fine-tuned this GPT-3 model, and we've produced another model called GPT 3.5, for example. We then generate new prompts and completion pairs, and then we actually rank them, you know, in order of, like, we provide rewards, right? These are good, these are bad. This produces a reward model, right? We then take the original model, the GPT-3 model, and we combine it with the reward model to produce essentially this new thing which we can use, which is now fine-tuned, right, based on the data that we've given it. Some history as far as large language models. So in the past, really basic language models were used to predict essentially the next word. They were very serial in nature. They didn't have an understanding of what was said before, or what information was provided before that word. Here's an example on the left of next token prediction, and another one was masked language modeling, where you essentially have to fill in the word, right? So the one was predicting the last word. The first one, sorry. So it had limitations. As I mentioned, it's unable to fully understand the context For example, when you provide a prompt, it's unable to fully understand what was said before to make the next prediction of the word, of the next word. Inputs were also processed sequentially. So they're on an individual basis. This is where it lacks that context, right? So in a lot of cases, the quality of the completions was not very good, right? So the talk is about ChatGPT. So let's focus a little bit on ChatGPT. So ChatGPT is or was based on a lot of the latest breakthroughs, right, that we mentioned, that Google discovered in their white paper, and that other companies had made in the space, right? So generative pre-trained transformer models, they were first launched in 2018 by OpenAI. I think you probably all know OpenAI. And they introduced they leveraged a couple of interesting innovations, right? One was the autoregressive large language model, right? And this allowed predictions to be made on not just the next one token at a time, but actually to take into account the tokens before it, and to come up with better completions, better predictions. We also have the advent of the transformer architecture, and then also self-attention, right? So the transformer architecture allowed the models to have a better understanding of relationships between tokens, and then the self-attention piece was essentially, it was able to weight, which was better, which were better than others, right? Which relationships were better than others. So if you put all this together, we ended up, so you'll see this is quite a nice GIF of an autoregressive model from DeepMind, so Google's DeepMind project, where it shows how it's able to, through the deep neural network, how it's able to predict the next word. So all these advancements essentially culminated in this GPT family of models, right? They enabled large language models like GPT-3, GPT-4, etc., to process inputs as a whole and build an understanding of the relationships between the tokens within or between the words. Okay. So, ChatGPT, it's based on GPT 3.5. Right? So GPT 3.5 was essentially fine-tuned on conversational-like or dialogue, let's say. So it's able to interact with you in a very conversational way, a very natural way, which a lot of people like. And this is really a breakthrough, right? If you've ever used in the past any kind of bots, that websites have exposed, they were not very great, right? But now with ChatGPT, you get it feels like it's a human on the other side of that chat. It's also able to answer follow-up questions. It admits its mistakes. It can't do math, as you've probably seen. But, who needs to do math? If we look at the observability space, how can we leverage ChatGPT? Well, there are multiple areas where we could potentially leverage something like ChatGPT, right? So we just covered the conversational UX part, right? Customers really like those natural interactions. So that can really be an excellent way. For example, querying data, but in a natural language. Code generation, we discussed Copilot, excellent use case, and I think it's something which will evolve over time and get better and better. Something which is probably very interesting for all of you is helping to implement intelligent problem resolution. So suggesting ways to resolve issues in production, for example, based on your observability data. And finally, this is not an exhaustive list, but finally, you're also able to enrich the observability context, right, which you gather around certain situations or the state of your system. And this allows your operations teams to more effectively handle, incidents, for example. Okay. Something to keep in mind, how many of you have played around with ChatGPT or GPT-4 or GPT-3? Okay, so a few of you. How many of you have ChatGPT Plus subscriptions, right, for $20 a month? Okay, yeah. It's pretty great. So if you haven't played around with it before, it's very important to understand, right? So users of our systems, of our software systems, very much expect when a system or an application receives an input, they expect the same output, right? This is kind of how computers work, unless it's a bug. Yeah. So a challenge with ChatGPT and this family of large language models is that if you provide the same prompt more than one time, you will get different completions, subtly different completions. I mean, it's designed to do that. But now, if you try to put that in a software system, and the user doesn't expect this behavior, it can be a bit jarring, right? Also, ChatGPT requires a lot of context, right? You have to build up that context in the form of the prompt, essentially, and the information that you provide in the prompt. And there's a limit on the number of tokens that you can actually provide in your prompts. All right, so there's some challenges there, so you have to go through multiple questions and answers to build up this context and to get to an answer, for example. Now, something we're all concerned about is the end of the world, right? So, generative AI and ChatGPT it's not Skynet, right? Yeah, it's not there yet, thankfully. LLMs in general, they're not perfect. They have a number of issues. So, if you played around it before, you'll see that they're apt to nonsensical responses, right, or hallucinations. They're also sensitive to minor changes in the prompt. They can be excessively verbose, right? And they're also challenged by ambiguity. We as humans handle this a lot better when we deal with our tasks. There's also a challenge in the security area, right, where, it's susceptible to prompt injection and hijacking. So there are a lot of concerns there. So given these imperfections, really a new discipline is emerging. And that discipline is prompt engineering, right? So this is an area where people specialize on writing prompts for these models, right, to essentially get the answers that they're looking for consistently. So when some of the basics for prompt engineering, we're looking to set the context, we're looking to set the behavior of the bot or the model. We also look to set boundaries. We can also define the output format, for example. If you want it to respond to you in JSON, you can do that, right? Machine-readable JSON. In the end, you do all of this, leveraging a few different things, but you need to, like system, assistant, and user prompts, and a set of, questions and answers. So how do we set expectations? So you can set expectations, multiple ways, but one of the ways is through system prompt. Here you can see an example where we actually say, we tell the model to behave like an AI assistant. We want you to solve challenges which operation teams are seeing. And, you're going to be given a JSON string, extract some important insights from this JSON string. We can also go a step further, and we can say, okay, well, as you can see in the bottom half on the right-hand side, we want you to respond in a certain way. Give us a title and a description based on the data that you provided. So here we can see, okay, we give it the data. You can see there's some JSON data of a security issue within the environment. And we can also see in the bottom right the completion. And we can see it does a fairly good job of extracting some insights from this pure JSON data. It says it's a denial of service in the title. There's a problem with this ID, display ID, etc. It's not perfect. We'd have to do some prompt engineering, and we'd have to really kind of polish it. But it's a start, right? So one other way that we can actually improve the quality of your completions when you're leveraging these models is through zero-shot, one-shot, and few-shot learning, right? So this is in lieu of actually fine-tuning a model like we saw earlier. So specifically in this case, no model parameters are changed. There's no training or expensive retraining or fine-tuning taking place, right? All you do is you provide examples in your prompt. So here we can see, oops. Here we can see example of few-shot and zero-shot. So we can see here in the second screenshot, we provided a number of examples of what we want to be returned to us, right, in the completion. And we can see also that in the previous example, sorry, I lost that one, but I had a screenshot before where it actually showed, it was more verbose, right? It was saying, it actually spelled out cross-site scripting vulnerability. And because we've now provided some examples, but we've used acronyms, in this case, it has actually returned XSS, right? It's just minor change in the behavior that we've actually made by doing this. But this is really powerful, right? And a cheaper way of actually changing the behavior than fine-tuning. Some rules of thumb when you're actually building your prompts. So be specific. Make sure you define exactly what you want, right? You also have to be as verbose as possible. Be very descriptive on what you want. Double down. Repeat yourself. I mean, it's a little bit weird, but you have to just kind of adapt, right, to how the prompt needs you to talk, right? Order also matters. You can try, when you're actually doing your prompt engineering, when you're looking at solving a specific problem with ChatGPT, in the DevOps space, for example, try out different strategies. Your mileage may vary. So, for example, in the order, if you put it before or after, you may get better results. It's not an exact science, unfortunately. It's a little bit like SEO. Also, give the model an out. This means allow the model to actually say, oh, I don't know. Because if you don't, it's going to hallucinate. It's going to tell you some wonderful story about sunshine and rainbows, right? And it gets really creative. Rather, give it instructions and say, if you don't know, just say you don't know. So I think in this slide, we look at something which is a little bit more interesting. We look at how we could potentially build an agent which is able to orchestrate the responding to a question like, how do I resolve issue X, Y, Z? So we can see in the diagram, we have a lady who's asking, how do I resolve this security issue? And she's asking this to a software system. This agent can reach out to any, observability data that it has available to it. All right, so it queries the data. This might be structured, JSON, for example, which is returned. This clicker is killing me. Anyway, I'm not going to go back. So if we look at, we then query, we basically query an embedding model. Right? So embedding model takes some text and it returns some vectors. And those vectors we can use then to actually, for different things, but for doing similarity searches essentially, right, from within a vector database. So what we do is we generate this embedding data using text that we've received, the agent has received from Dynatrace, for example, and also from the user. This embedding data we can then use to actually query a vector database to work out, do we have similar data in the database? And then we can bring all this data together. We can build a prompt which we can then send to ChatGPT and use ChatGPT to actually formulate the response, right, based on knowledge that we've actually gained, in Dynatrace, for example, or in other databases that we may have, right? And we can use this knowledge then to generate a response to our user and say, this is how you solve this problem, right? We can take it a step further also, and we can use our knowledge database to actually fine-tune our own version of the model, on our domain. But as I mentioned, this may not be necessary. It can be very expensive as well. Okay. So hyperscale is obviously investing very heavily in this space as well. All right, so Azure invested, over 10 billion in OpenAI in the really early days. And there's some interesting news out there as well, where Bill Gates and them all sat down and actually saw this in action and were very amazed, right? I think Kevin Scott on his podcast, I recommended, listening to it. They also invest heavily in their AI platform, right? So they're building a bunch of tools around prompt engineering and also running fine-tuning models, a number of different interesting solutions on the Azure side. In AWS, they're obviously not one to be left behind either, so they have announced a number of services in this space and hardware, dedicated hardware for these types of workloads, and the same with Google. So they have more than 25 products in this area, right? So there's a lot of innovation happening, and this makes it a lot easier and a lot cheaper for you as customers of these hyperscalers to consume these types of capabilities, right? You don't have to host your own model, for example, or train your own. So as far as Dynatrace is concerned, we're also looking at how we can improve the platform, leveraging these capabilities. So we're introducing the Copilot, for example, Davis Copilot, which is very similar to the Copilots that you see from GitHub, Microsoft, etc. Right? Really, it's the person sitting over your shoulder helping you to do your job. And in a lot of cases, doing the boring stuff, right, that you don't want to do. So there's a lot of interesting things happening in that space. So let's see, do you all think this technology will solve all the world's problems? No? It's going to take our jobs? Just yet? Also no? Yeah, I would agree with you, right? So it's not a panacea. It's a tool, another tool in the tool belt, right, to help you get your job done. Obviously, prompt engineering, as we saw, it's a new discipline. You need to learn how to use this tool effectively. We also have to understand how our intellectual property can be affected by this type of tool. Right? When you're building systems which consume enterprise data, for example, be very careful. Make sure that you take into account that fact. So in general, it's, as with any tool, it's very important to understand the risks when you use it. And just, let's see, shout it out. I mean, how much do you think it costs in energy costs to train a model? Just a number, a big number. 10 million? 20 million? Yeah, 20 million, give or take, right? So I've seen a few numbers out there. I think GPT-4 was around 100 million, I think. At least I've seen on the internet, which take it with a grain of salt. Costs a lot of money, right? But the good thing is that we're able to host these models, and it's a one-to-many kind of situation, right? It's much cheaper to run them than to train them. Anyway, thank you very much for your time. I really appreciated your focus on a Friday afternoon, and also me standing between you and the pub or the bar, right, and a beer. I hope you have a great last session, and yeah, it was a pleasure. Thank you.
Yeah, nice one. There's not many questions, but we also don't have much time, so that's absolutely fine.
Fine.
Sorry, guys, keep it quiet. Shh. Yeah, they're asking if there is some way to ensure that you don't accidentally leak data to ChatGPT. Obviously, there's you can install it, let's say, locally in your servers, but it's obviously 3 or 4 million the starting pricing point. So, so any advices you can give the audience?
Yeah, no, there is, right. So both Azure and OpenAI both provide capabilities where you're able to actually train or fine-tune based on your enterprise data without actually sharing that data back to the rest of the people who are using those same models.
Yeah, but you need to pay the millions, right? There's no
No.
There's
do it, yeah.
Okay, yeah. I didn't know
specifically in Microsoft's case, I know that's 100% for sure.
Okay, and they are also asking if if there is a good way to actually ask the prompt to generate prompts. To that prompt engineering is about fine-tuning the queries or adding context to the initial question. So how do you approach that?
So the way I've used that is basically I've used ChatGPT to generate prompts for DALL-E, for example, for image generation. So yeah, definitely you can do this, and it can be very effective if done correctly. Mm-hmm.
All right, well, I think there were no more questions. Well, one question was how is Dynatrace using, but obviously you covered that on one of the last slides, so it's almost covered.
Yeah, watch the space. I think, all the vendors are really looking at this very closely and how we can actually leverage this technology in effective ways, right? And I think it's going to be great for us.
And for humanity, let's say. Well, even if it's scary.
Yeah.
All right, thank you very much, Gareth. It's a pleasure to have you.
Yeah,
Thank you.
Thank you. Okay.